Okay, Isosceles Triangles homework. How did it go? Number 9? What else do you want me to work? I did not, Kendra. Nope, so you can ask any problem you want. 9, 6, and 16D. All right, let's start with those, and then if y'all come up with some more when I have the worksheet pulled up, you can ask for some more, okay? Okay, let's look at number 6 first. So we know some things about this triangle. We know that it is isosceles. I bet I know what you're asking, and I might not have fully taught that yet. So that's probably why you're asking that. It's an isosceles triangle. This segment is an angle bisector. And I bet you found X okay. We know that the base angles are congruent, so 52, 52. You add those up and subtract from 180, and you get 76, and then you bisect 76. But I'm guessing that's not what you were asking about. You were probably wondering how we know that Y is 4. And unfortunately, we'll learn this on Thursday for sure. But if you have an isosceles triangle, it's symmetrical, right? Same on the left as it is on the right if you're orienting it that way. So if you cut the angle in half, you're going to cut the whole triangle in half because it's isosceles, because it's symmetrical. The left equals the right. You could fold it over and it would fall perfectly on the other side. The left would fall on the right. That's what symmetry is. So Y is just 4. And the only reason we know it's 4 is because that's an isosceles triangle. Had that not been isosceles, we would not know how to find Y. We just wouldn't know it. Okay, number 9. Number 9, let's look here. This is a what? Oh, a pentagon. It already tells you. Okay, it's a regular pentagon. So we learned in our notes that regular means all sides congruent, all angles congruent. Equilateral and equal angular. Very good. So I could add tick marks to all my sides, but I'm not going to add it to all the sides because I don't need it for all the sides. So do you see an isosceles triangle there? AED. So we know that triangle AED is isosceles. So I could redraw it facing us just so we can see the whole picture. 108 and then tick mark, tick mark. So this is classic. Subtract from 180 and divide by 2. And we get 36. 36, 36. Now, if we know that every angle is 108 and every side is congruent, then this triangle is going to match it, right? We know that's 108. We've got tick marks because all sides are congruent. So really, triangle AED matches triangle BCD. So 36, 36 as well. We could find those angles as well. And now to find X, we would just do 108, and that's hard to see. But 108 minus 36 minus 36, and it happens to also be 36. So it happens to trisect the angle. Is that a word? Trisect instead of bisect? I don't know. How did I know the sides were congruent? Right here, Kendra. Because the problem stated that it was a regular polygon, and we wrote that in our notes, that all sides are congruent for a regular polygon. And that's how we were able to solve that. What else from the homework? Title your notes, Triangle Inequalities. This is probably my favorite lesson of the whole unit. It is very straightforward, it's very common sense, and students really are successful with this lesson. So I can't wait to teach it to you. All right, you are a landscape architect. Something weird happened with the font. There we go. And you're designing a deck. You want to place the lounge chairs in the 2 largest corners. Where should they go? So what's a landscape architect? Someone that designs for the outdoors, right? For green spaces. Okay. But a landscape architect is different than just a plain architect. Okay, anyways, so he's not going to really carry around a life-size protractor. He's not going to measure angle A, angle B, and angle C. He wants to put the lounge chairs in the largest angle, but all he knows was the measurements of the deck. He knows how long each side is, because that's easy to measure. probably measure it these days with like one of those laser beam ones, but you could also just use a measuring tape. Okay? So yes, Neil, that's what we're about to learn. How the sides give a clue as to which angle is the largest. So, everyone put your hands together like this. What is the distance between your fingertips right now? 0, right? They're touching. The distance is 0. So now, as you open your hands up like this, and the angle gets larger, what happens to the distance between your fingertips? As the as the angle gets larger, the distance is more. And as the angle gets smaller, the distance is less. More, less. More, less. And that's exactly how the angles in a triangle work. That's exactly how the angles in a triangle work. So write this down in your notes. I know it's kind of common sense. The largest angle is across from the longest side. The medium angle is across from the medium side, and the smallest angle is across from the shortest side. So it's a direct relationship. The angle to the side across from it, not the side next to it, the side across from it. That's really important. I'll give you just a minute to write this down in your notes. Okay, so let's practice. If I give you a triangle and you know the angles, could you label which side is the shortest? What would we need to do first? So what would we need to do first here if we want to find the shortest side? We would need to use triangle sum theorem, right? It's important to kind of know what theorems you're using as you're solving these problems. So we'll use the triangle sum theorem and we'll find the missing angle. The missing angle is, Aaliyah, thank you. The missing angle is 56. Now we have enough information to label our sides. So our shortest side would be across from our smallest angle. 56 is our smallest angle. So we look across the triangle and boom, there's our shortest side. Our medium side will be across from our medium angle. And our longest side will be across from our largest angle. Now, the drawings will not always be to scale because we don't want you to always use your eyes to choose the medium, short, and long. So you'll have to use the angles to find out which one is the shortest and the longest, not your eyes, okay? All right, next thing. So here we have a picture of some drawbridges that are over the Chicago River in Illinois. Chicago, Illinois. So what's a drawbridge? What is it? It's a bridge, right, that sometimes pulls up, that opens to let tall ships through, right? Okay, so if we dissected this drawbridge and we kind of looked at the space between here, so if we looked at that space and we looked at the length of this side of the drawbridge, let's call it A, the length of this side of the drawbridge, let's call it B, and we'll call this C. What would need to be true about sides A, B, and C for this drawbridge to work effectively? What would need to be true? A little bit larger. Yes. No, A doesn't have to equal B equals C. You probably just had a typo. We would want the sum of A and B to equal C. That way when they let the sides of the bridge down, they connected perfectly, right? Now, what would the repercussions be if A plus B was less than C? Oh, yeah. So there would be space in between. There would be a gap, and depending on how large that gap was, cars could fall into the river, right? There would be a problem, unless it's like on a action movie and the cars like jump, you know, the space between. Anyways. All right, what would the repercussions be if A plus B is greater than C? So when they let those drawbridges down, there would be some crashing, or there would be some overlapping, and the cars would, crash into the bridge. So we would want neither of those to happen. It would be a very specific side lengths of those bridges whoever designed that. And if there was shifting of the earth, that would really affect how those came down, right? Okay, let's look at another thing that deals with sides of a triangle. Now, right now, what's the sum of 7 and 8? Okay, so the sum of 7 and 8 is 15. And is that greater than or less than 10? It's greater than 10. So that makes a triangle. 7 plus 8 is 15. It's larger than the third side, so we have a triangle. Wonderful. Now, I'm going to slowly start to make our sides shorter and shorter, and we're going to see what happens. 6 plus 7 is 13. We are still greater than 10, and we still have a beautiful, nice triangle. Okay? Next. The sum is 12, which is still greater than 10. Although this is still a triangle, it's becoming more and more obtuse. It's becoming, the altitude is shorter and shorter. It's a short, squatty little triangle. Okay. Oh, man, we're really getting small. The sum of the sides is 11, which is still greater than 10. And that's still a triangle, right? Albeit a very short triangle, but it's still a triangle. What am I going to do next? Oh, my goodness. 4.5 plus 5.5. It's 10. Is 10 greater than 10? And did I form a triangle? Is that a triangle right there? No, it's a segment. So it does not form a triangle. So if we had to write a theorem about this, we would probably say that if you add two sides of a triangle, the sum must be what? Then the third side. Yes. Or this way. Greater than. The sum must be greater than the third side, or a triangle is not formed. A drawbridge is formed, right? There's our bridge right there. It's not a triangle. Oh, I thought I had another one where they were shorter. But anyways, if it was too short, let's say that this was 10, and this was 4, and this was 5. If it's not equal to, but if it's less than, they're going to try to reach and try to reach. They're going to try to make a triangle, but they won't be able to make a triangle because 9 cannot reach across 10. It's too large of a space. Okay. So you may write down this theorem. It's an official theorem. It has its own name. It is the Triangle Inequality Theorem. Write it down. I'm going to move past the Triangle Inequality Theorem, and we're going to try some examples. Can a triangle have sides with the indicated length? So it's asking, will these lengths form a triangle? So it's a yes or no question. Now, we could check all three of them, right? We could do 3 plus 8. Is that greater than 7? Yes. 8 plus 7. Is that greater than 3? Yes. 3 plus 7. Is that greater than 8? Yes. We could check all three of them. But we shouldn't ever do something that's not necessary, right? We should be efficient. Very good, Aaliyah. So the only two that's necessary to check are the smallest ones. So when you're given a problem like this, I want you to circle the smallest two. Circle the smallest two, add them up, and decide if it's greater than the third or not. If it really is greater, then yes, they form a triangle. I could form a triangle out of those lengths. Let's try the next one. Smallest two. The sum is 9. Is that greater than 10? So no, this would not form a triangle. The 3 wouldn't be able to reach the 6 because they have to stretch across 10, and 9 can't stretch across 10. All right, next one. 2 and 7 is 9. Is 9 greater than 9? No, it is not. So 2 no's in a row. That would not form a triangle. 2a plus 2a. What's that last one? Good. It's 4a. Is 4a greater than 3a? Well, we would have to say that a has to be greater than 0, but we're talking about triangle sides here. So triangle sides couldn't be negative anyway. So a is definitely greater than 0. So 4a is always greater than 3a, as long as a is greater than, well, greater than 1, actually. Sorry, greater than 1. Yeah, it would still work. As long as it's greater than 0, it's still going to work no matter what. Now, the sides will get smaller if you multiply them by a fraction, but the sum of those first two sides will still be greater than the third one. Okay? So the answer is yes, no matter what. And we're restricting a to be greater than 0. Okay? Try some more. Two sides of a triangle have lengths 8 and 10 centimeters. What are the possible lengths for the third side? What are the possible lengths for the third side? So let's talk about what the largest the third side could be. So I've got sides of 8, I've got sides of 10. What's the largest the third side could be? 18, good. How did you get that? You added them up, right? So 18 is the max. What's the smallest the third side could be? It can be greater than 3. The smallest the third side could be. What number could pair with 8 and it would reach? No, it can be smaller than 3. 2.2? There you go, 2.00001. So 2 is actually the minimum, as long as you don't include it. So the third side is x. X needs to be greater than 2, not greater than or equal to. It needs to be greater than 2 and less than 18. So write this down. This is how you solve one of these when it says what are the possible lengths of the third side. So how did we get the minimum? Oops. How do we get the minimum? We subtracted. How do we get the maximum? We added. It doesn't get much simpler than that. Add them up, that's your max. Subtract them, that's your min. No. There is no base of the triangle, Lily. The only triangles that have bases are isosceles triangles. It's not isosceles. I just drew a sketch. 10 is one of the sides. Okay, Nathan. So why would it be 18? So if I drew 18, we've got 8 and we've got 10. Now, the 8 and the 10, that wouldn't reach. That would form a segment. But if it's anything less than 18, like 17.9, then 18 is bigger than 17.9. It would reach. It would be a very short triangle, but it would reach. So 18 is the max. It can't equal 18. It needs to be less than 18, aka 7.9, 7.8, 7.7, 17, sorry. Okay? 18 is the max. You don't include it. You don't put the equal sign underneath it. And 2 is the min. Find the longest side of ABC if those are the angles. I'm just going to start working these because I know we're running out of time. I would draw a picture. And I would label our angles. How are we going to begin this problem? Triangle angle sum theorem. All right. Oh, I didn't say what it equals. Equals 180. So we are going to solve for x. How many x's are there? Let's see. 2x plus 3x, there's 5 x's. And then plus 80. If I combine like terms correctly. Hopefully I did that correctly. X is 20. So now we plug it in. 2 times 20 is 40. 40 minus 10 is 30, and so that makes that one 80. So we did all that work just to find the angles. Okay, cool. Now that we have the angles, it says to find the longest side. So the longest side is going to be across from the largest angle. Good. So the longest side, draw an arrow away. The answer is AB. And that's how you name a side. 2 capital letters with a segment on top. I know you can't do that in the chat. Okay. Given triangle HAL, that's what I call my oldest daughter. Her name's Hallie, but we call her Hal for short. Given triangle HAL, let's see. I better draw a picture. AH is greater than AL. So I'm just going to make up numbers. This one is greater than this one. Okay, cool. And AL is greater than HL. Oh, so I need to get smaller than this. Okay. So notice I just made up numbers that fit those conditions. List the angles from smallest to largest. All right. So the smallest angle will be across from the shortest side. So angle A would be the smallest. Angle H would be the medium. And angle L would be the largest angle. Notice how I used an angle symbol. I didn't just use a capital letter because that would be a point. Okay? Last problem. Arrange the letters' values from least to greatest. Now, when you have two triangles involved, you can't look, the whole figure is not a triangle, right? No, it doesn't form a triangle. So you need to look at one triangle at a time, and you can order the letters in one triangle. Never compare a letter from one triangle to a letter from another unless that side is being shared between both. Like G. I can compare G in both because both triangles have that side. Let's just talk about it. Let's look at the smallest triangle first because we're going from least to greatest. So we're going to start with this triangle right here. All right, if we find the missing angle, what is it? 180 minus 77 minus 19, and we get 84. So the smallest side is A, the next largest is E, and then G. So I just ordered those from smallest to largest in that one triangle. Now, the only way this works is if the largest side of one ends up being the smallest side of the other. You can't have any overlap or we wouldn't know how to order them. And don't worry, they'll always work like that. Okay? Oh, they go to Gleason. Okay, anyways, so G is across from 22. So it's the smallest one, so I can just keep going. The next largest one is going to be S. And then the last largest one is going to be E. It almost spelled eagles, but not quite. I mean, it's the letters that would make up eagles. Anyways, I hope that made sense. The common one, like the G, will always be the shortest side of one and the longest side of other because you're going to leave off with it and then you're going to start with it. G is the biggest one in the smaller triangle. It's not the biggest side on the picture. It's the biggest one in triangle 1. When you go to triangle 2, look, it's across from that measly 22. It's the smallest side in the triangle 2. The largest side in the whole picture is L. L is the largest one in the picture. How do we know which triangle to use? You always start with whichever one looks the smallest. If you pick the wrong one, it'll be obvious why. Because like I said, this is the key right here. You're going to leave off with that one on one triangle and you're going to start with that one for your next triangle. Look for the one that looks the smallest to start with, and then you go to the next triangle. You use both triangles. You just have to begin somewhere. Okay, I think that was the last one. Yeah, that was the last one. Okay, we have a quiz tomorrow. The quiz, if I remember, is over triangle sum, exterior angle theorem, and isosceles equilateral. So it's over the first 2 lessons that I taught, Friday's lesson and Monday's lesson. Quiz tomorrow.